This lesson is a continuation of section 3.7 on solving percent equations. The previous lesson we talked about how to solve percent problems using a proportion. Today we're going to solve them with a different way using a percent equation. Literally where we take the words that are in the problem and we're just going to make an equation straight from it, and then we'll be able to solve that and get x by itself or our unknown by itself. Every word in the problem stands for either some number or some operation, and ones that we've talked about in the past. So some people find this method a little more straightforward. There's each method has its pros and cons. The proportion method, I think you have to kind of surf around a little bit and more find where the numbers go in your proportion and figure out, okay, which number is my base, which number is my part, where's the percent, and you have to kind of surf around a little more and make sure you figure out the correct setup. With these, I think these equation problems, it's a little easier to set them up. But then sometimes you have to change your answer at the end. If you want a percent, you have to change the decimal where that is, or change the number into a percent just in general, or change it, or just kind of understand when you get a decimal what it means in this problem, and if you have to change your answer or not, knowing what you're looking for in the problem. So these, again, each one has its pros and cons. I think these percent equations maybe just a little more straightforward in terms of setup, but sometimes the answer you have to interpret a little more. The proportion ones you have to interpret a little more or analyze more when you're setting up the problem. But I think then once you've got the problem set up, then those are a little easier. So it just depends on whichever way you'd like. I would, when we're doing this section, as I told the students in class, the previous lesson I wanted them to solve all the problems on that assignment using proportion method. On this one, on this assignment, the one that goes with today's lesson, I'd like you to solve them using the percent equation. So, and then after today, you can kind of pick and choose which way is your favorite way, which way is your most comfortable way to solve these problems. But for each of the lessons, I want you to try to solve them using the method that we practiced that day. So let's look at an example problem here and kind of just figure out what I'm talking about in terms of making a percent equation. You may even recognize this problem. It's one very similar to one we had yesterday. It says, what percent of 56 is 49? Yesterday we set this up with some kind of proportion. We said what percent is what we're trying to find, so we put P over 100. And then that's to the percent. In this case, that's what our answer is going to be, our unknown. We're trying to find out the percent in this problem. The number right after of is 56, so that would be our base. And then the last number in our problem here, 49, must be our part. So here's how this one would set up if we were going to use the proportion method. But instead today, we're going to get the exact same answer, but instead using the equation method. What I'll talk about in class is seeing if students can remember what some of the words stand for in terms of what operations. We talked about earlier this year, like certain words mean certain operations. Like when you see the word sum, that means addition. Or when you see the word decreased by, that means subtraction. And there were other even smaller words in there that we could tell what operations they stood for. The word of is also another important word like that. Usually when you see that in a problem, it means multiplication. So in this problem, the word of, right below that, I'm going to put a multiplication sign. The word is, we've talked about this before, if you have a problem where blah, blah, blah is 49, then that is usually stands for an equal sign. And there's where our equation part of that's what makes this an equation, is we'll have an equal sign in it. We'll have some stuff equals something else. So we can see this is going to fit into being an equation. The number 56 is just going to stand for itself. The number 49 is just going to stand for itself, so I'm just going to bring those down and plunk them in my problem here. And then my last thing that I have here is what percent. That's what we're trying to find out. That's our unknown, correct? So in this case, when I put that in, that's just going to be the variable P. So you may notice, here's what we're talking about today in terms of the setup being straightforward. In that problem, I picked every single word off, every number off, and just plunked it right into an equation, just dropped it straight down. Everything stood for either a number or a variable or an operation in my problem. So here's the equation, and if I just kind of rearrange it, just looking at this part, P times 56, what's the way we usually write that? We usually write that as 56P. I'll rewrite that. Not 55, I want 56. 56P. That equals 49. Now this is just a one-step equation that I can solve. To get P by itself, I'm just going to divide both sides by 56. And I find that P is going to give me some percent. I think in this case it ends up being, in my calculator, I'll get 0.875. I'll double check that here in a second, but I'm pretty sure that's what I'm going to get. Here's what I mean, though, in terms of the proportion method being a little more straightforward with our answer. And the equation method, now I have to maybe analyze a little more with my problem. So, and just kind of double checking again, 49 divided by 56, yep, that is 0.875. If I'm trying to get a percent for my answer in these problems, what my answer that gave me here, I'm trying to find the percent. What this gave me though in terms of an answer is just in decimal form. It is the percent, but it's in decimal form. So remember to change a decimal into a percent. It's kind of like taking this number in your calculator and you could punch in times 100 because a percent means out of 100. Or also I know some people just know to move the decimal 2 spots to the right. So in this case, if I jump it 2 spots to the right, my actual answer is the percent is 87.5%. So again, notice with the types of weight or the method that we're going to use today, I can still get to the same answer as yesterday. If I scroll back, and we did solve this problem yesterday. Here it was right here. Okay, we end up getting the answer P equals 87.5, but in the proportion method, once I solved the proportion, I just got P equals 87.5. If I'm using the equation method, when I get a percent for an answer, notice that it gave me in decimal form, and I had to change it at the end to get to a percent. So again, that's just one little difference with these methods. But as long as you can understand that, or if you feel comfortable being able to do that, to know that, oh, I got a decimal for an answer, I have to change my answer to a percent, then that's fine. This method can still work just fine the way it is. Again, it's very direct in terms of setting the problem up. Let's look at another one here together on this page. So this one says, what number is 15% of 80? So in this case, again, we'll look for those those keywords. Of means multiplication, so I'm going to drop that down. I'm going to put a little multiplication sign here. Is an equal sign, and that's what's going to make this an equation. The number 80 is just going to stand for itself. And then in this case, 15% also in the equation method. 15%. If I have a percent in the problem, I'm not going to put 15 in there. I'm going to deal with it as a decimal. So I'm going to change it into 0.15. This is just the same as if maybe you've done problems in the past, or I know that said maybe in 7th grade and 8th grade students have done problems in the past, or sometimes they have to take 20% of a number. Well, you don't times that number by 20, you times it by 0.2, you times it by its decimal form. Same kind of thing here. If I'm going to use the percent in an equation, I'm going to have to change it into a decimal to make that work. So in these problems, I have to change it into a decimal, but as long as you can handle that, then this could be a perfectly good method to still find the answer. My last thing up here is what number. So again, that's like my variable. That's my x, I could say, or my whatever variable you want to put in there. But that's my unknown. That's what I'm trying to try to find. So again, notice how easy this setup is for these problems, though. Here was my sentence that it gave me. There's the equation. Everything drops down right into a nice, right in line. However it reads, that's where everything kind of fits in my equation. So in this one, if I just kind of rewrite it here, x equals 0.15 times 80. In this one, all I have to do is I already have this thing solved for x. I just got to take 0.15 times 80, and that's going to give me my answer. And so in this case, I think I end up getting, 12. I think I'll end up getting for an answer. So 80 times 0.15 should give me 12. I'll double check my own mental math here, but 80 times 0.15 gives me, yep, should be 12. Good. So again, these problems, maybe you have to rearrange decimals or move decimals a little bit more when you're working with a percent, but the setup for them is actually pretty straightforward. And then it's just like solving maybe a one-step equation. I'm going to show us one problem where I'm going to solve it using both the two different methods. Here's the method we learned in the previous lesson, set up with a proportion. Here's what we're talking about now in this lesson, using a percent equation. So I'm going to solve this problem up here at the top using both these methods. So here's my problem, example number, I guess it's label number 4 in this case. 72% of what number is 180? I'm going to solve this over here, and I'm going to solve it over here. And again, after you use, today when we're in this lesson, I want the students to use the percent equation method. But after today, they can use whatever method they're more comfortable in. But here's just an example to show that regardless, we are going to get the same answer, no matter which method we use. Okay. So if I go to step number 1 here, maybe I'll do this one in green. So I'm going to set up some kind of proportion from that problem. Well, in this case, I have my percent. It's 72. So I'm going to put 72 over 100 equals. And then again, when I was figuring out the part or the whole, which number What number is going to go on top of my ratio, what number is going to go on the bottom. Well, the number directly after the word of was going to be my number that's going to be my base in my problem. So in this case, what's directly after the word of is just what number. That's my unknown. That's what I'm trying to figure out. So I know yesterday actually I put b a lot, but you can use x or you can use any variable. I'll stick with b since to kind of stay consistent here. And then what number is left over from my problem is still the 180. So that must be the part in my problem. As I cross multiply and solve here, I'll get 72b equals 18,000 in this case. And when I divide both sides by 72, b is going to equal, I think it's 250 for this problem, 250. Again, I'll kind of double check that, but that looks like the correct setup. Again, notice one thing with this problem too. When I set up with a proportion, I don't have to change the percent at all. It says 72 in the problem, so that's exactly what I plug into the proportion. So again, that is one kind of nice thing. I don't have to worry about the decimals or moving them around. So, and yes, the answer does end up being 250. Now I'm going to use the same problem, or take the same problem and solve it with a percent equation instead. I'll do this one in blue. So if I look at this problem, 72%. Again, in this type of problem though, if I'm going to change this into a percent equation, I'm going to have to write that as 0.72. The word of is going to be a multiplication sign. What number is like my variable, so I'll just use x in this case. I'll stay consistent here and use x. Is an equal sign, and then number 180 is just going to stand for itself. Again, the setup for these problems may be a little bit simpler, or maybe a little bit more straightforward. So I have 0.72x equals 180. If I just kind of rewrite the problem, because 0.72 times x just gives me 0.72x. I'm just going to divide both sides by 0.72 to get x by itself, just like we would with any other one-step equation. Now x is by itself, so x equals, and if you punch it in, I guarantee you'll get 250. So again, there's kind of showing that both methods will give us the same answer. It does not matter what method you would use. I'd like you to practice both methods just so we kind of can see them both and then make our own informed decision on which one we like. But just know that they're both have their pros and cons. Either one will work. We'll look at just a couple of other examples here. Again, setting up a problem with a percent equation. And notice, or remember in the last lesson, when we solved with proportions, I had a few hints, or I had 3 different hints that you could use to help you set up one of those proportions. In this section, I also have some kind of hints or reminders, as I'm going to call them in this case, of things to help you when you're setting up a percent equation. So I know I don't have them in red, but I guess I have them in a red box around them. So this is something though definitely you could copy down into your notes to kind of remind you. If you're using percent equation method, then we got to make sure we do a couple of these things, like put the percents in decimal form if that's what you have in your problem. If you have the percent in the problem, you have to change that to decimal form. Or if you get that as an answer, you have to change it back to a percent. Okay, so being able to kind of transition between those 2 different types of versions of the answer. Remember that the word of means multiply for an operation. Remember the word is an equal sign. And then whatever our unknown is, it'll usually say like what number or what percent. That's going to stand for our variable or our unknown. So there's a few reminders. If you're using this method, there are some things that may help you to kind of remember how to set these particular types of problems up. That's something I would like you to jot down in your notes, especially when you are using this method. So again, we'll set up 2 more problems here together just to make sure we have the right idea. This problem number 5 here says 22% of what number is 55? I'm just going to go left to right here. And kind of, I think we're getting the idea in terms of what everything stands for in our equation, but I'm just going to go left to right to kind of show you, here's how easy these can be in terms of the setup. 22%. Again, like my first reminder says down here though, if I have a percent in my problem, I have to make sure that I change that into a decimal. So in this case, if I have 22%, I'm going to write that as 0.22. The word of is going to be a multiplication sign. What number is going to stand for some variable for us? So in this case, I'll just use x. Is going to be an equal sign, and 55 is just going to stand for itself, 55. So again, there's how easy the setup can be for these types of problems. I'm just going to rewrite it once over here. 0.22x equals 55, and then it's just like solving a one-step problem. I'm going to divide both sides by 0.22. So I'm going to get 55 divided by 0.22, whatever that answer is. Again, notice though I changed the percent into a decimal at the beginning of the problem. That is something I have to do to take into account in these types of problems also. 55 divided by 0.22 gives me 250, nice round answer. And I think that answer seems to make sense for our problem, so good, 250. We'll do one more problem here together. I'm just going to kind of move the reminders down a little bit, maybe just kind of out of the way here, so just kind of take those and slide it all over here for now. Hopefully you have those copied down by now. If not, you can just rewind the video and look back and get them again. This problem right here, I'm going to solve it by using a percent equation. The number 8, again, everything in the equation or the sentence is just going to drop down right into the equation. So, and it stands for some number or some operation in it. 8 is just going to stand for itself. The word is going to be an equal sign. What percent? This is what I'm trying to find. So that's my variable p in this case. I always use p for that because that reminds me to change it to a percent once the problem's done. The word of is going to be my multiplication sign. The number 30 is going to be the number 30 itself. So there's my setup for this problem. 8 equals p times 30. If I just rewrite that a little bit, 8 equals p times 30, we would usually write that as 30p. This may look a little more familiar then. And now if I'm getting p by itself, I'm going to divide both sides by 30. And p is going to equal whatever, it's going to give me some kind of decimal answer in this case. And again, because it's p, I'm going to have to change it into a percent. So in this case, I get 26, I should say, here's what I get for my calculator, 2.6 repeating. To change that into a percent, again, one way you can do it is just hit, as soon as you get that answer, hit times 100 in your calculator, because a percent literally stands for out of 100 per 100. So I can just hit times 100 in my calculator. All I'm gonna find is that's gonna move the decimal over 2 places. So you could also just do that. The answer for your percent is gonna be 26.6 repeating percent. So again, there are some problems solved using percent equations. The last 2 lessons have both been solving percent problems, just using 2 different methods to do so. Again, in today's assignment, I'd like you to use this method, but as we go on from here, the review or on the quiz, then you can use either method you prefer, so whatever one you're more comfortable with. But I would like you to try both, so then you can at least make an informed decision on which one you do like better.